Chapter 3 notes, Task 2, linear inequalities. Linear equalities just means linear equations. But instead of having an equal sign, we use a less than sign, a less than or equal to sign, a greater than sign, or a greater than or equal to sign. There are two things to remember when we use these inequalities. First of all, you need to consider the type of line you will draw. If you see a if you see a greater than or equal to or a less than or equal to, we use a solid line. If you see a greater than sign or a less than sign, you use a dotted line. The reason why the solid includes an equal, that means it includes that number, so we're going to put a solid line. Greater than or equal does not include that number, so that's why we use the dashed line. The next thing to remember is that if you see a greater than or greater than or equal to, you're going to be shading above that line. We'll do some examples in a minute. If you see a less than or equal sign, you're going to be shading below. Big time hint right here, you can also use Desmos to do this for you. To type in a symbol, like type it in as this and then hit the equal sign. When we're going to put in the greater than equal to sign, for example, you're going to hit this sign and then the equal, and it'll pop up looking like this in Desmos. Okay, again, Desmos is your friend. When you see an equation, you're going to open up Desmos and type this in, and it will sketch the graph for you. All right, so when you type it in, you will see the graph goes through the y-intercept at -4 because that is our y-intercept indicated by the b, and the slope is positive because it's up 2 and over 3. Since this is a greater than sign, everything, let me find a color here, everything is shaded above the line. Because it says y is everything greater than that line. All right, moving on to the second example. Again, you type this into Desmos, and when you do that, the graph will look like this. And if you notice, this says 3x plus 6y is less than 12. So in this case, we used a dash line, and the slope is negative. That's why our line is going down. And the shade this time will be below the line because less than, as indicated up here in your notes, indicates everything below. So everything down here gets shaded. Next, a coordinate point is a solution if it lies in a shaded section or on a solid line. So we're going to take a look at these 6 coordinate points and determine if they are in fact solutions to the equation 5x minus 2y is greater than or equal to 20. So before we get started, I need to make sure that you have opened up Desmos in your computer. So do that now if you haven't already. So once you've opened Desmos up, and again, if you can split screen your Desmos and these notes, that would be great. You're going to literally type in exactly what the equation is in this first box. Again, to do the greater than or equal to sign, I'm going to hit the shift button, and that greater than sign, and then an equal sign after it. And it's 20. And as you can see, just putting that greater than or equal sign in alone does the shade for me. So again, we're checking to see if these guys are solutions. So I'm going to scroll over and see that our first point we're looking for is 0, -4. So I'm going to add a box, and I'm going to just pop in that coordinate, 0, -4. And then I'm going to look over here, and I can zoom out or in, and I see that this coordinate point does not fall within the shaded area, nor does it fall on the line. So 0, -4 is not a solution. So let's try the next point. It's 6, 5. So I'm just going to actually come up here. I already have my brackets. 6, 5. We can see that it falls directly on the line. So yes, 6, 5 is a solution. Let's try 0, -15. Make sure you put the comma between. And we'll have to search for that dot, and we see it's right down here, and it's in the red shaded part, so yes, that is a solution. Next one is 10, 0. So literally, again, we go and plug that in, 10, 0. It's in the shaded. Yes, that guy is a solution. Just going to put Y because I'm running out of space. We have 2 more, 2, 10. That guy's up here, not in the shaded. So we're going to put a no. And lastly, 10, 15. It's directly on the line. So yes, definitely a solution. Desmos is our friend, guys. We can also use this to go backwards. If we see a graph, we can write the equation of it. And to do so, we know that it always starts with a y. Since this is a solid line, we know it's going to have either greater than equal to or less than equal to. Since it's shaded above, our notes indicate that means greater than. We always are going to have an x and plus or minus the y-intercept. Well, if we take a look here, this is your y-axis and your x-axis. So we're looking for where does it cross? It crosses right here. And that's if they're counting by ones in this graph, it's up 1, 2. So we know that the y-intercept is at +2. We're going to find the slopes. We want to see, if I put a dot right there, exactly where it crosses. And it looks like it crosses exactly right here. It's kind of hard to see on this graph paper. We're going to do rise over run, and it looks like it goes down, so I know my slope is negative. 1, 2, 3 over 1, 2. So to write the equation, you have to find the y-intercept and the slope. Let's do the same for the second example. We always start with y. In this case, it is dash, so we know we will not include an equal sign. It is shaded above the line, so we're going to go ahead and just put the greater than sign. We're going to see where it crosses the y-axis. If this is a 0, we know it's going down. We'll count 1, 2, 3, 4. I always do the y-intercept first. And then I'm going to count the slope. I see that since it crossed right here, I'm going to count up 1, 2, 3 over 1 because that's our next dot where it hits that grid paper perfectly. So 3 over 1 is the same as just a 3. And since it's going up, it is positive, and we always have an x with it. Lastly, we want to mention that a system just means multiple equations. And when you see that, you're going to do the exact same process that we just learned. You just have to do it multiple times, usually twice. The graph below shows a system of inequalities. and it prompts you to create the system of inequalities that is shown by the graph. So there are two lines, so we need to write an equation for this line and this line. So again, we always start with y. In this case, it's a solid line, and everything is shaded below it, so that is less than or equal to. I like to find the y-intercept first. It intercepts the y-axis at +2. I know we're going to have an x, and we need to find the slope. The slope is positive, and it looks like it goes from here to here. So the rise is 1, and the run is 2. So that would be 1/2x. Next, we're going to find the second line, and what I notice about it already is that it is negative. So I know my slope is going to have a negative with it. It's dash, so no equal sign, and everything is shaded above, so that means greater than. I like to do my y-intercept first. I start at the 0, count down, 1, 2, 3. It's down 3, so they're going to subtract 3 at the end. My slope, like I said, is negative, so I just set that up with a negative sign, and I'm going to find where it hits here and here. The rise is 2 and the run is 1, so I have a -2x. Notice that some of the shades overlap, and I'll highlight it with yellow here. Any point that falls in the shaded region that is shared by both lines is in fact a solution.